This is lesson 2 of chapter 2b. Our topic is measuring spread. Our essential outcome is that you will be able to find and interpret the standard deviation of a data set. Alright, so our goal today is standard deviations. So here are some foot lengths in centimeters for a random sample of 7 14-year-olds from the United Kingdom. So, first we need to find their median. So in order to find their median, the first thing we want to do is we want to actually put these numbers in order from least to greatest. So let's look. Smallest number is 20, and then it looks like we've got a 22, we have a 24, a 24, a 25, a 25, and a 28. Alright, if we look at these numbers now, we can start crossing off, figuring out what's in our middle. Those two go away, away. Our median is 24. It's simple as that. Average, we have to add up all the numbers. So we go 25 plus 22 plus 20 plus 25 plus 24 plus 24 plus 28. Add those all with your calculator now. As you do that, start to think about how many numbers you're adding together. We are adding together 7 numbers. We get 168. We take 168, we divide it by 7, and we get that our average is 24. And there you have it. So, it's as simple as that. So if we look at these graphs on here, we have to find the mean and the median for each of these dot plots. So as we do this, what we need to do is we need to think about, okay, are these symmetric? If we look at this first one, we notice there's 1 on each end, and there's 2, and there's 2, and there's all these bunch ones in there. And there's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And if you look, they're all the same distance from each other. So if you had to guess the median, the middle of this data, what do you think it would be? Well, if you guessed 4.5, this will be right in the middle right there. You guessed correctly. Our median will be right here in the middle. So our average would be 4.5. Now, because this data is also symmetrical, if we think about this, we're going to have 2 numbers be in our middle. We're going to end up with a 4 and a 5. And so our median, which we can denote as m, is also going to be 4.5 for this one. So it's not too bad. If we look at the next data set, we see once again this one's symmetrical. Okay, but whereas this one was like more of a tall symmetrical, this is more of a short one. And this one, it's symmetrical once again along 4.5, so your mean once again is going to be 4.5, and your median is going to be 4.5 because that's also the middle. Now if we look at this one, this is kind of inverted. It goes down like this. Alright, there's 1, 2, 3, 4, 5, 7 dots there. 1, 2, 3, 4, 5, 6, 7 there, and then 3 and 3. So the same on the average. So if we look, what would be the middle between 8 and 1? Well, once again, that would be that 4.5. So your average would be 4.5, and your median would be 4.5. So notice, just being able to look at these drawings, we didn't have to do any calculations. Alright? And these are very, very different data sets, but they still have the same mean and the same median, which is quite rare. And so this just kind of tells you, lets you see that it is possible for completely different graphs to have the same mean and the same median, even if they have completely different distributions. So, the standard deviation is what we're really talking about today, and what this is the average distance away from the mean. Okay, so it's the average distance of each point away from the mean. And so our definition for standard deviation is that it measures the average distance of the observations from the mean. It's calculated by finding an average of the squared distance and then taking the square root. So its formula is right down here. And to find the standard deviation of n observations, we can follow this process right here. So we put in our values for each point. So our first one's at 1. Our next dot is at 3. And then we have one at 4. another one at 4, we had another one at 4, and 5, and 7, and 8, and 9. And so we're lucky. This one tells us our mean, and so it says our mean is 5. So what we do next is we do our number that's in this first column minus the mean. So 1 minus 5, and that's going to equal -4, okay? And we do our next one, 3 minus 5, and that's going to equal -2. We go 4 minus 5, and that's going to equal -1. Same thing here. Same thing here. All right, we get down to 5 now. 5 minus 5, that's going to give us 0. 7 minus 5, now we're going to get to some positive numbers. All right, so we did our first step. Now what we need to do is we take this value and we square it. So -4 squared, well, a negative squared is a positive, and 4 squared is 16. So there we go. Same thing here, 2 squared then, so we get 4, 1, 1, and 1. 0 squared, well, that's just 0. 2 squared is 4. 3 squared is 9. And 4 squared is 16. So now what we do is we take all this third column and we add them all up. So we go 16 plus 4 plus 1 plus 1 plus 1 plus 0 plus 4 plus 9 plus 16. And we get 52. So all these numbers added up together give us 52. So if we look, the next thing we do is we divide 52 by the number of observations minus 1. So we did 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to do 52 divided by 9 minus 1, and then we take the square root of that whole thing. So that's the square root of 52 divided by 8. Well, what's 52 divided by 8? That's 6.5, so the square root of 6.5. And that gives us a long decimal number. We're going to round it to 2 place, 2.5. And there you have the standard deviation. All right, so some things to remember. Standard deviation. The lower the standard deviation is, the closer the observations are to the mean on average. So the smaller that standard deviation is, the closer the numbers are. And the higher the standard deviation is, the further away the numbers are from the mean on average. All right, so if we look at this, these are those data sets we talked about earlier about the mean and the median. This first one, notice all these numbers. Remember, our mean was right here in the middle. And these first numbers are pretty closely connected around that. So this is going to have a small standard deviation. It's going to be a low number. Whereas this one, okay, these are pretty densely, these are just kind of evenly spread out. This will have just kind of like a middle deviation. It's going to be a bigger number than the first one. And this last one, okay, these numbers are all pretty far away from that mean. So this is going to have a large standard deviation. It's going to have the largest one of all. Keep that in mind as you do, if you look at a set of numbers, how large ahead of time you think you should have for a standard deviation. And that will help guide you as you find your answers. So, write your summary and questions. Your essential outcome is that you'll be able to find and interpret the standard deviation of data set, things you should be thinking about. What does standard deviation mean? How do I calculate standard deviation with a calculator? What kind of data sets produce small standard deviations, and which one's a large deviation? That is the end of day 2 of chapter 2B of probability and statistics.